thought this would be a good time to do an explanation of, this is video 3. So this is NYLOG. There's a NYLOG red, NYLOG blue. It doesn't matter. Just use one. This one is more compatible with the CFCs, HFCs, and the other one's HFOs for the blue. But I'm just going to show you here, lubricant wise. You see these nuts, the way they're attached like this? These are supposed to spin. This was seized up. Somebody over tightened this. This was over tightened before, and it was actually, I couldn't get this to move. I had to get a wrench to break this free and get it nice and rounded and moving. So I put a little bit of the NYLOG on the back fitting, and if you look really close, let me zoom in. This is really flattened out because it was tightened, over tightened. Let's get over there. Where that touches right there, that little edge has been smashed. It's like a razor. It's actually smashed. The metal has been annealed. It has been gold and over tightened, and it should have a nice smooth to it. But so I put a little NYLOG on the back side of this to act as a lubricant, so, and a somewhat of a, you know, just help on that axis. So now it spins nice. I also put NYLOG, let me find it, find my finger, come on, where are we at? I have it on telephoto, so it's really hard. So I have NYLOG on the back side, so this nut can slip on the back side. I have NYLOG on the O-ring side, so there's a little NYLOG right there where this O-ring is going to slip down onto right there. And that's more than enough. This stuff is, the red NYLOG is really thick and it gets really messy. But that's 10 times more NYLOG than you'll ever need. That was actually too much. So we have NYLOG on the back side of the O-ring, NYLOG on the back here where this edge, the shoulder is going to come down on, where I said it was over tightened back there too, where, get back here, where it was over tightened, and it's nice flat and sharp from this being over tightened on it. And let me back out on my camera, it's too much. Okay, so now I'll be putting it together, and that'll be going up inside there. Let's see if I could do this one-handed. You want to make sure and look all the way around that you do not pinch your O-ring. You're in level. You do not use the nuts by grabbing the first thread, and if you can't get this nice square and flat and straight, you do not use the nuts to pull it in and straighten it out and force it. This is how you over tighten. This is how you pinch O-rings. This is how you gull the metal and you do damage on the back of the metal. You push it in square, even if you have to get somebody to help you, to push it in flat and straight and square, 360 degrees around, and only finger tight if you can. Bring it up as to the back of this shoulder right here, meets inside here, and it's nice and square, and then you put your wrenches on it. Don't use the wrenches and the threads to pull it up into place. This is how leaks are formed and damage gets done to the metal. So I think this was video number 3, maybe, and so that's that part there. I didn't find damage on the O-ring. So do I have a crack still? I can't see, I can't find. Under pressure testing with nitrogen under low pressure, I can't find it. Is it one of those ones that only the metal opens up after hot refrigerant? Because this is on the high side. So when there's high pressure refrigerant, the aluminum expands and there might be a crack I can't see or find right now under static conditions, but it leaks later on. Or was this be a part before by a technician and he replaced an O-ring and he left green dye and oil inside the threads, and later on it came out and there's actually no leak and I just wasted my time? I may never know. So let's get off to the next one. I'm going to throw this on the vacuum pump and leave it on the vacuum. I got a couple other jobs in this town to do, so I'll do a few other jobs, leave this on the vacuum pump for a few hours, come back and charge it up and see what we find.